field office last month. That was when one of our rigs was fishing for 50,000 bucks worth of drill string. I would not repeat your exact words, but you sure were successful in one thing. You got my attention.
You really might as well report a fishing job this year. I'm getting a little tired of these reports of these company people.
As a matter of fact, you got everybody's attention.
Way of pipe and collars are being handled. This is no reason. There's no reason for it to continue. I want these fishing jobs to stop.
After the boss left, I thought about the problem. Yeah, Kathy, need you to call down on rig number 5. Tell Burl Sparkman that pusher down there, and I'll be on down there after a little bit. We got some problems down there on our drill pipe and our drill collars. I need to talk to him about it. So if you get the word to him, tell him I'll be on down there after a little while.
Drilling superintendent knows that drill pipe and drill collars must be cared for and handled properly if fishing jobs are to be avoided. He also knows that the place to start is with the tool pusher. The pusher is closest to the job and should know about proper handling of the drill string. A trip to the rig floor can also be helpful. For instance, this driller pointed out that sometimes drill string problems start when the pipe and collars are unloaded at the rig. So, right away, it pays to unload your pipe carefully to avoid damaging it. The driver spotted a thread protector that's fallen off during the ride to the rig, so he puts it back on. This can prevent damage to the threads that could lead to a fishing job. You see, drill pipe and drill collar threads are precision equipment. They're often machined to 1/1000th of an inch tolerance. Damage here before the pipe ever gets in the hole probably means a lot of trouble later. So keep those protectors on. As for unloading, how many of you do it this way? Simply pulling the chocks and letting the pipe roll off the truck is fast, but the pipe can run wild, get bent, or suffer thread damage. Also, it's real easy for somebody to get hurt. Here's a better way. A forklift can pick up several joints off the truck with not too much banging together. All the joints are under control as the operator moves them to the pipe rack. The pipe is lowered to the rack with little chance of damage to the pipe. Also, the chance of injury to a person is minimized. The second step in getting longer life from your drill string is clean threads on the tool joints and drill collar connections. A grain of sand or a metal filing can damage the threads. So clean the pin end with a solvent and bristle brush. Don't use a wire brush because it can cause damage. Once it's clean, really eyeball it for damage. Also, clean the thread protector before it's put back on the pin. Not a whole lot would be gained by cleaning the threads, only to use a dirty protector. After it's clean, put the thread protector back on. Now clean the box end. Again, use a bristle brush instead of a wire brush. And don't forget to clean the box-in thread protectors. Once clean, put them back on. Next, look for damaged pipe. This joint is as crooked as a dog's hind leg, so set it aside. But some types of damage can be repaired. For example, this shoulder can be fixed. File the high spots down, removing as little metal as possible. Touch up all the way around to ensure a good, flat sealing surface. Use a flatness ring to check the shoulder for low spots. Low spots could cause the shoulder to leak, the threads to wash out, and the joint to fail. You can also use a power grinder on damaged shoulders. First, screw a guide into the box. Then put the grinder shaft into the guide and start the grinder. It's not long before you've got a good shoulder. When you find minor damage to a thread, use a special stone on a power grinder to repair it. This is faster than using a 3/4 file, but be careful. It can break right above the drill collars. The pipe whips because it's lighter and more flexible than the heavy, stiff drill collars. This pipe is designed to minimize the problem. Notice the long tool joints and the bulge in the middle. When this heavy wall pipe is placed in the string above the drill collars, it smooths out the whipping action and should reduce failures in this part of the string. Another thing that can prevent pipe damage is maintenance of your pipe handling equipment. Take the slips, for instance. Check them frequently to be sure the teeth or gripping elements are in good shape and properly installed. If the teeth are worn, damaged, or improperly installed, they can score the pipe. This sort of damage can lead to a break and a fishing job. Also, be sure to use the right size of slips. For instance, if you're running 4.5-inch drill pipe, make sure the slips are usable with pipe of that size. The same thing holds true for the drill collar slips. Periodically, check the slips. Simply wrap the test paper around the pipe. And carefully set the pipe on the slips. Then pick up the pipe and pull the slips. Look at the test paper. In this case, the even marks on the test paper show that the slips are okay. After the slip test, check the master bushing. What he's looking for are signs of wear like gouges or worn spots. Here's a master bushing in orange that's in good shape. The slips in yellow evenly contact the sides of the pipe. No problem here. But here, the master bushing is worn. The top of the slips wedge inward and bottleneck the pipe. Bad news. More bad news can occur if the inside of the rotary table is worn down. So, while the master bushing is out, check the rotary for wear. Here again is a table with everything in good shape. But with a worn table in blue, once again you can get bottlenecked pipe. So it pays to check out your rotary from time to time to get long life from your string. With your rotary in good shape, and with your pipe and collars clean and inspected, you're ready to go in the hole. First, make sure the catwalk is clean. You don't want any junk or iron on there that could damage the drill collar. Roll the collar off the rack and onto the catwalk. Notice that the thread protectors are on. Pick up the collar into the V-door. Be very careful not to let the collar get away from you so it won't hurt someone or get damaged by banging into the rig. Sure glad the thread protector is on. With the collar in the V-door, make up a lifting sub. Latch on the elevators and lift the collar onto the floor. A piece of soft line across the V-door helps in keeping the collar under control when it reaches the rig floor. After the bit is made up, focus your attention on the best rules to follow when making up the collars. Lower the collar into the hole and set the slips. Attach a safety clamp. The clamp keeps the collars from falling into the hole if the slips fail. Next, break out the lifting sub. As you set it back, use a little care to keep it from being damaged. Be selective about the dope or thread lubricant you use. This batch has metallic zinc or lead in it to give it body. The dope has to be spread liberally over all the threads and on the shoulder to ensure a good leak-proof joint. Be really careful when stabbing collars. Bouncing thousands of pounds of drill collars together at the joint can lead to trouble. Walk the collars in with chain tongs. This way you don't run the risk of ruining the threads. Using a spinning chain or the rotary to spin up a collar makes it spin too fast and can gall the threads. Of course, to buck up the collar to final torque, latch on the regular tongs. Exact tightness is important, which is why you should use a tong torque gauge. If the connection is too loose or too tight, the collar could be damaged. When handling drill pipe, the same sort of care pays off too. For example, when tripping pipe, wait until it stops moving before setting the slips. If you don't, the slips can gouge the pipe and lead to a fishing job. Next, dope the joint. And latch on the backup tongs. Be careful when stabbing. do not drop the pin on the shoulder. Instead, make a good stab with the pin going right into the box. Spinning tongs are real handy to use to spin the joint up. The makeup tongs are used to buck up the joint to proper tightness. Here again, a torque gauge is real handy in getting the proper makeup torque. Going in the hole, this crew really knows what they're doing. Let's watch. Good. He doped the threads. Good stab. After spinning it up here with a spinning chain, they use both sets of tongs. They don't use the rotary to hold the pipe stationary or to spin it up. If the rotary were used to spin up the pipe, this is what can happen. If the pipe turns in the slips, deep scars just waiting for a chance to part and create a fishing job. Be careful, too, when making up the Kelly. For example, worn threads on the Kelly sub can do an awful lot of damage, since the sub mates with every joint that goes in the hole. If you've handled your pipe correctly, then you shouldn't have any pipe problems downhole as you drill. Of course, sooner or later, the bit gets dull and you have to trip out. The same sort of care in handling pipe is necessary during this process. When coming out, just as when going in, set the slips only after the pipe stops moving. That was pretty fast, but was the pipe really stopped? Use both sets of tongs to break out a stand. Once loose, spin the joint out. When the threads disengage, lift the tool joint pin clear of the box and set it back. Be careful not to let the stand get away from you. Also, make sure the setback area is clean and free of debris that could damage the pipe. Another thing, if you have to move a stand once it's set back, use a special pipe lifting tool to do it. It'll prevent damage to the shoulder. As you break out the pipe, be kind of like the old Indian scout. Look for signs of trouble. For instance, this joint's kind of hard to spin out. So the crew cleans the pin to look for problems. And as you can see on the shoulder of the joint and the rotary, the dope was forced out by drilling mud pressure. This is what could happen, a washed out thread. You can avoid this by making up your pipe and collars to the correct torque. Here's another sign of trouble. A messed up shoulder. This damage could cause a washout or, worse still, a break. Don't run a damaged joint into the hole. Here's a stretched pin. You can see that a thread gauge doesn't fit in the threads, a sure sign of stretching. Proper makeup torque prevents this problem. When the well has been drilled to final depth, take care when laying down the string. With this laydown system, the pipe is hoisted up and the crew swings it over to rest in a padded bucket. Then the joint is carried out the V-door and goes down a wire line to the rack, ready for hauling to the next job. Pretty nifty laydown system because it's fast and prevents damage to the pipe as it's being laid down. So there's no doubt that good handling of the drill stem pays off. With everyone from the drilling superintendent to the tool pusher, driller, and the crew doing their job well, your motto can truly be, no fishing this year.
The term fishing comes from the early cable tool practice of probing with a hook or to catch a broken drilling line in hopes of retrieving the drilling tool attached below. On modern rigs, fishing is the art and science of removing broken or stuck equipment or small non-drillable materials from the wellbore. A fish can be anything from part or all of the drill string to bit cones, pieces of tools, any material accidentally dropped in the hole, or even small pieces of naturally occurring iron pyrite. There are many types of fishing tools. Which tool to use depends on the kind of fish in the hole and the downhole condition. Every fishing job is unique, and to cover all aspects would take more time than allotted here. So only some of the more commonly used fishing tools and practices will be discussed. Poor boy junk baskets are just one of the many tools employed to retrieve small pieces of equipment, that is, junk, from the hole. While being rotated slowly and applying weight, the fingers bend inward to trap the junk inside. The junk, or boot sub, will retrieve small pieces of junk. It's usually run just above the bit during normal drilling and milling operations. The junk is stirred up by the mud stream and rises to the area above the basket. In this area, the mud stream widens, slows down, and can no longer carry the larger pieces. So the junk falls in the cup and is retrieved when the bit's pulled. A jet-powered junk retriever is more effective when the junk's too large for the cup in the junk sub. The retriever is run to within a few feet of bottom with circulation and rotation to clean cuttings off the top of the junk. Then a ball is pumped down the drill string. The ball shears a pin to divert drilling fluid out jet nozzles. This action causes a pressure drop or vacuum inside the tool. The tool is then rotated slowly to bottom and raised and lowered several times to stir the junk up. Finally, it's lowered over the junk. The lower pressure inside the tool causes mud outside to rush in the bottom of the tool and lift the junk. Folding fingers permit only one-way passage of the junk to the inside of the tool. Fishing magnets are helpful when small metallic pieces must be retrieved. The permanent magnet picks up junk as cuttings are circulated off the top of the junk. When junk is large or oddly shaped, a jet bottom hole cutter may be needed. The tool contains a shaped explosive and is lowered to the junk on an electric line. When detonated, high-velocity gases break up the junk, which is then recovered with one of the conventional junk retrieving tools. A common fishing job occurs when drill pipe parts during drilling. This type of break is called a twist-off, and usually results from metal becoming fatigued due to the constant bending and torquing of the pipe. When a twist-off occurs, the pipe above it is tripped out and measured. It would be measured under tension while being pulled so that the depth to the top of the fish can be accurately determined. It's necessary to run an electric log to locate the top. An inspection of the break gives a good reverse image of what the top of the fish looks like. The top of a bird or split fish should be milled down, preferably to a thicker portion such as a tool joint. It requires great care and exact knowledge of the depth to the top of the fish to prevent the mill from bypassing the fish and damaging the pipe below. Mill cutting surfaces are inlaid with very hard tungsten carbide. The configuration of these mills gives an indication of how they are used. When the top of the fish is fairly smooth, a releasing overshot is run below the drill collar string. It should have a large bore so other tools can be run through it and into the fish below. The fish is caught and held by segmented slip grapples, as shown here, or by spring-type grapples. Anchor seals between the fish and tool so mud can be circulated through the fish. Overshot can be released from the fish if the fish is stuck and can't be pulled. This overshot can be released from the fish if the fish is stuck and can't be pulled. If the fish is burred or flared, it may be necessary to use a mill insert in the overshot to clean up the top of the fish. Careful measurements are taken to determine how far the fish must extend into the tool before it can be caught by the grapple. The guide helps center the fish under the tool. It's good practice to run a hydraulic jar with a large bore just above the overshot in case the fish gets stuck during fishing operations. The jar's length should be added to the overall measurement of the fishing tool assembly. Also, a jar accelerator may be installed above the drill collars to dampen the jarring effect on the derrick and increase the magnitude of the blow delivered to the fish. Accelerators and jars later. We've now assembled a safe, basic string to fish for parted drill pipe. From top to bottom, there's drill pipe, a jar accelerator, drill collars, a jar, and a releasing overshot. Catching the fish may be as simple as lowering the overshot with rotation to the right over the fish, then raising it so the grapple will move down to wedge against the fish, and circulated to condition the hole before the fish is pulled out. On the other hand, it may require hours of patient raising, lowering, turning, and feeling with the fishing assembly. Impatience and rough handling can damage the top of the fish. Under these conditions, accurate measurements taken of the fishing assembly help to determine whether the tool is passing by the fish or if the grapple is not holding. The problem may be that the fish has parted in a washed-out section of the hole or has fallen behind some obstruction. After a period of fishing with the overshot, it's possible to fairly well determine if this is the case. If so, alterations must be made to the fishing assembly. The first and least expensive alteration is to put a double bend in a joint of drill pipe and run it in the string between the drill collars and overshot with the point on the guide to the high side of the bend. By repeatedly raising the assembly, turning it, then lowering it, the entire circumference of the hole can be investigated. Otherwise, a wall hook guide may be run below the overshot. It's rotated slowly and carefully lowered until it tags the fish. Then the string begins to torque up as a result of the fish binding in the wall hook opening. When this happens, the rotary table is locked and the fishing assembly raised until the torque is released. When the torque releases, the top of the fish should center up under the overshot. Now the assembly is lowered and the fish engaged by the overshot. Here also, accurate tool measurements help position the assembly for the catch. If the cavity is very large, a hydraulically actuated knuckle joint may be needed to extend the wall hook and overshot out into the cavity. Most knuckle joints require dropping and pumping down a restriction plug to activate the knuckling action. After the fish is engaged, the plug is retrieved with a wireline overshot. Once the fish is caught, the hole is circulated clean before starting out of the hole. If circulation can't be fully established, it's almost a sure bet that cavings and cuttings have stuck the fish. Here's where our insurance, the jar and accelerator, pays off. Drill collar weights set down on top of the fish to cock hydraulic jars. Then a moderate pull is taken on the fishing string. Stretching the string compresses trapped gas in the jar accelerator, momentarily storing high-intensity energy. The gas is compressed by the piston as the string is pulled upward. At the same time, the upward pull on the string causes oil in the hydraulic jar to seep between a piston and sleeve. The sleeve restricts the first few inches of travel, but once the piston is pulled beyond the sleeve, there's little restriction. So the stretch in the fishing string, aided by the compressed gas in the jar accelerator, snaps the drill collar mass upward, jarring the stuck fish upward when the mandrel knocker strikes the knocker sub. Then weight is again applied to the jar to recock it for another blow. If jarring doesn't free the fish, the next step is to find out where the fish is stuck. The caution about not running fishing tools with little or no internal restrictions pays off here, because now we must go through them to the inside of the fish to find the stuck point. A free point indicator with a string shot is run inside the fish on electric cable. At various intervals, the assembly is stopped and the drill string is stressed by applying torque and tension. When the pipe is stressed, the indicator detects the rearrangement of the pipe's molecules. A surface instrument indicates the change either visually or audibly. The stuck point is the point where no molecular change or stress is indicated. The string shot is positioned opposite a tool joint, some 1 or 2 joints above the stuck point, and left-hand torque is applied to the drill pipe. The shot is fired to loosen the joint, and the left-hand torque backs off the upper portion of the drill string. The back-off should always be made a joint or 2 above the stuck point, so enough pipe is exposed to act as a guide and to ensure a clear, clean connection for subsequent fishing tools. Shot, and then the freed section of the fish are pulled. To retrieve the rest of the fish, a washover string is run. One type consists of a back-off connector tool and a length of near hole-size wash pipe. A wash overshoe is made up on the bottom of the wash pipe and is used for drilling. The total length of wash pipe should be about 500 feet or longer, depending on hole conditions, as at left. However, shorter lengths may be necessary, as at right. The wash pipe assembly is lowered over the fish while rotating and circulating as in normal drilling. Washing over progresses the full length of the wash pipe until the back-off connector tool engages the top of the fish. If all the fish has been washed over, the hole is conditioned and the fish pulled. If there's still more fish to be washed over, a tool joint locator and string shot are run to a point 1 joint above the bottom of the wash overshoe and the back-off performed. Then the washed over section is pulled. This washover, back-off, and pulling is continued until the entire fish is freed. Now let's go back to the point where the fish was first caught with an overshot and say that circulation was established, but the fish is stuck and can't be pulled. Probably the fish is wall stuck, because that's the most prevalent type of sticking where circulation is not impeded. Wall stuck pipe occurs where the hydrostatic pressure of the drilling mud is greater than the formation pressure. The greater hydrostatic pressure moves the drill pipe to the side of the hole and the liquid part of the mud into porous formations, leaving a mud cake that builds up around pipe. This wall cake, plus the differential pressure, can stick pipe. Preparations should be made to spot oil or a commercial chemical around the fish, which will penetrate between the pipe and the wall of the hole and break up the wall cake. Usually, the drill pipe is filled with the oil or chemical and moved down the pipe every 30 minutes by a few strokes of the mud pump. If oil spotting and jarring doesn't free the pipe within about 48 hours, the stuck point is located and the freed portion of the fish backed off and pulled. Then washover operations commence to retrieve the rest of the fish. If a drill collar parts, the collar string can usually be fished out with an overshot. However, it may be necessary to use a fishing tool that goes inside the fish, should the fish be only a fraction of an inch or so smaller than the wellbore. The simplest inside fishing tool is the taper tap. Lowered into the collar bore, it's slowly rotated in the proper direction to make its own threads as it engages the fish. Some taps have open tips for limited circulation. None will allow a free point indicator to pass. Also, it should always be run with a safety joint. A safety joint is a two-piece sub made up with large, specially designed right-hand threads. Rotation to the left, combined with an upward pull on the string, will back it out. With its safety joint is engaged, the fish can be pulled. But if the fish is stuck and jarring doesn't free it, the fishing assembly is broken out at the safety joint and the fishing string pulled, leaving the taper tap and part of the safety joint in the fish. A washover job can be done. Another inside fishing tool is a releasing spear. It is lowered inside the fish until the bumper ring above the slips contacts the fish. Left-hand rotation, combined with an upward pull, causes the spear slips to expand and wedge into the fish for retrieval. The spear can be released from the fish at any time by applying downward weight and right-hand rotation. Fishing for stuck pipe does not always occur when the bit is on bottom. Pipe can become stuck off bottom during a trip, or drill collars can be pulled into and stuck in key seats. Key seating is the result of drill pipe under tension wearing a slot into the wall of a crooked hole. The slot is usually smaller than the main bore hole, and drill collars can't pass through it. If the driller is not careful, he can jam the top collar into the key seat so tightly that any amount of weight applied will not make it drop free. If this happens, a back-off is made 5 or 6 joints above the stuck point. The back-off is made well above the stuck point so that the top of the fish is in the main bore hole and out of the key-seated portion of the hole. This is done so that the fishing tool can be placed on the fish in the normal part of the hole. Since the fish has an undamaged tool joint looking up, a bumper jar and key seat wiper may be run and made up in the fish. Once engaged, the body of the jar is raised the length of the jar mandrel, then suddenly dropped to strike a downward blow. Jarring does knock the fish free. The string is lowered with rotation so that the blade reamers on the wiper ream the key seat out. Then the collar string will pass through on the trip out. If jarring does not free the collar string, it'll be necessary to perform a washover. Since the fish is stuck off bottom, an anchor wash pipe spear can be used to prevent the fish from falling once it's washed free from the key seat. The anchor spear is latched inside the wash pipe by means of slips. It remains latched until it's made up on the fish at the beginning of the washover job. When the spear is made up on the fish, the slips release from the wash pipe. Washing over continues until the fish falls free. When this occurs, the slips again expand to grip the interior wall of the wash pipe to prevent the fish from falling out of the wash pipe to the bottom of the hole. If the entire fish can't be retrieved in one washover job, then a back-off is made above the stuck point and the wash pipe is set in the rotary table. Drill pipe is run down to and made up on the spear. The spear is raised to release the slips, and the spear, with the backed-off portion of fish attached, is pulled out of the wash pipe. The wash pipe remains in the hole, and the spear can again be run to retrieve the rest of the fish. Sometimes, after a back-off has been made above the stuck point and the freed section of pipe pulled, the inside bore of the fish, still in the hole, may become plugged by cavings and settlings. This makes it impossible to go back inside the fish to make further back-off and pulling operations. Should this happen, a drill-out tool can be used to reopen the fish. The drill-out tool is run to the top of the restricted fish and made up on it. A hex kelly is run in on wire line. It is inserted through a self-aligning bushing which is built into the kelly drive. Rotating the drill string causes the kelly and mill to rotate also. Pump pressure is applied to wash the cuttings and apply weight on the mill. When the kelly has drilled all the way down, drilling fluid will exit through the tattletale and cause pump pressure to drop. If there's more debris to be cleaned, the kelly can be retrieved by wire line and a pup joint, or short length of drill pipe, made up between the kelly and mill. This assembly can then be run back in and milling resumed until the restriction is removed. Then the mill and hex shaft are retrieved with a wire line overshot, leaving behind the outer case of the tool still attached to the fish. Normal back-off procedures can be performed to retrieve the rest of the fish. If a drill-out tool isn't available, a plugged fish can be retrieved with an external cutting tool. The cutting tool is run on the bottom of the wash pipe. Enough wash pipe is used to get below the obstructed fish. The washover, the cutting tool is slowly raised until a bottleneck, or as in this example, spring dogs, engage a tool joint. Then a strain taken on the drill string moves the knives into cutting position. The tool is rotated slowly under strain until the cut is completed. Then the wash pipe, cutter, and blocked portion of the fish are pulled. When logging tools or similar wireline instruments become stuck in the hole, cable-guided fishing can be used to retrieve the cable and instrument. One cable-guided fishing assembly consists of a regular overshot made up on drill pipe and a rope socket, sinker bar, and spearhead overshot attached to the upper part of the cable. A spear point rope socket is attached to the lower part of the cable. A cable hanger is attached to cable to prevent it from falling down the hole, since it's necessary to cut the cable to install the rope assembly. In use, the upper cable assembly is threaded through the inside of the first stand of pipe and overshot, while a C-plate keeps the lower part of the cable suspended in the hole, as at A. Then at B, the upper cable assembly is attached to the lower assembly, the C-plate is removed, and the first stand run in. After the C-plate is replaced at C, the spearhead overshot is released from the spear point rope socket, and the upper assembly is threaded through the next stand of pipe. This process continues until the overshot engages the fish. Once the fish is caught in the overshot, the cable is pulled out of the fish at a safety splice above the fish and reeled to the surface. Finally, the fish is pulled in the conventional manner. When a wire line, rope, or cable is dropped into a rotary drilled hole, the old reliable rope spear can be used to retrieve it. By jamming the spear into the mass of rope, the rope will be snagged and caught by the barbs. Then the rope and spear are retrieved. If allowed, some fishing jobs could go on for days and even months before the fish is successfully retrieved. However, there's a point where fishing must stop, and this is determined by economics. The accumulative daily fishing costs should be continually compared with the cost of replacing the tools and of sidetracking and redrilling. Once the fishing costs reach approximately 50% of the cost of sidetracking and redrilling, fishing should be abandoned. Remember that the proper tools are not always available, and that the best tools and procedures sometimes fail. But close adherence to the methods outlined should result in a high percentage of success. The term fishing, as applied in the oil industry, refers to the operation of removing broken or stuck equipment or any non-drillable object from the bore of a well. The term originally applied to the early cable tool practice of probing in the hole with a hook or a spear to catch a broken drilling line. Today, however, fishing is a highly specialized art requiring specialized tools and equipment and expert operating personnel. In this program, we will discuss tools and techniques used in cased hole fishing. A cased hole is a hole which has been lined with steel casing cemented in place. Casing serves to prevent collapse of the well wall and as a barrier against fluid entry from formations that may have been drilled through. Cased holes are normally wells that have been completed and capable of producing oil or gas. A common problem is stuck tubing due to sand fill or contaminated mud in the annulus. This must be cleaned out to remove the tubing and repair the well in order to obtain further production. Many fishing tools and techniques are available today which permit a variety of solutions to specific fishing problems. The proper tool and technique to use depends on the type of fish to be retrieved and on the downhole conditions. Cased hole fishing usually involves smaller diameter tools and lighter loads than open hole fishing, and the fishing string is frequently tubing which will not take the rough treatment and the heavy torque imposed on the drill pipe used in open hole fishing. Loose junk is a particularly hazardous problem in cased holes because of the close clearances between the casing and the inner string. Junk may be bit cones or pieces of other tools left in the hole as a result of tool failure, or any undesirable material such as hand tools accidentally dropped in the well. The Poor Boy junk basket is the simplest tool to use to recover loose junk inside open or cased holes. The basket is run in and rotated slowly as it is lowered to bottom. As weight is applied, the fingers will bend inward to trap the piece of junk inside and thus be recovered from the hole. There are a number of special tools for recovering loose junk from a well. These include the core type and jet-powered junk baskets and the magnet retrieval tool. The core type junk basket has a cutting head that is used to cut a short core of the formation which is recovered along with the junk. Both the core and the junk are held inside the body of the tool by one or more catchers. The jet-powered junk retriever is effective in removing large pieces of junk. It works by producing a high-velocity jetting action which lifts the junk into the retriever from the bottom of the hole. The tool is run to bottom and a ball is dropped into the drill pipe. When the ball seats in the piston, pressure increases and forces the piston downward. This diverts the fluid flow to the jet nozzles to create, in effect, reverse circulation into the bottom of the tool. The Venturi effect of fluid flow through the jet nozzles causes fluid to flow from the annulus into the tool. This carries the junk into the retriever. Junk that enters the tool is caught and held by the retaining fingers. The hydrostatic junk snatcher also uses reverse fluid flow to force debris and junk into the junk basket. Differential head between fluid inside the drill pipe and the annulus causes reverse flow when the trip valve is opened. The jar section is used to strike the downward blow needed to open the trip valve. When the actuator valve is opened with the tool on bottom, hydrostatic pressure of the fluid column outside the tool will force fluid to flow into the junk basket. Velocity of the fluid will carry loose material into the basket, where it will be held by retainer fingers. A permanent magnet may be used to pick up metallic junk. It is important to circulate first to wash away cuttings that would prevent contact with the magnet. Rope, wire line, armored cable, and similar items which have broken and fallen to the bottom of the hole may be recovered with a rope spear or grab. A standard fishing assembly consists of a catch tool, in this case an overshot, bumper jars, oil jars, drill collars, and accelerator jars. The bumper jar is an expansion joint which permits limited vertical movement of the upper part, the barrel, without moving the lower part, the mandrel. The splined mandrel forces the lower part of the bumper jar to turn as the upper part is turned. A slight jarring action can be obtained when the upper part is raised to the limit of its travel. Dropping the string quickly will produce a sharp downward jar on the lower section of the tool. In some cases, this jarring action may free a stuck fish. A string of pipe which has parted in the hole may be relatively simple or extremely difficult to retrieve, depending on downhole conditions. Pipe which has separated or twisted off because of mental fatigue from the constant bending of the string is often free in the hole. The solution may be simply to engage the top of the pipe with a catch tool and to pick it up. If the top of the fish is uneven or has a jagged edge, it may be necessary to smooth the end with a milling tool to permit engagement by an internal or external catch tool. The condition of the top of the fish may be determined by inspection of the break on the pipe that is retrieved from the hole, or by running a lead impression block. The impression block is a block of soft lead run on drill pipe or tubing. The fish top will make an impression in the block, which will give an indication of the condition of the top of the fish. A flat bottom or concave bottom mill can be used to smooth off the top of the fish. Cutting is accomplished by means of fragmented tungsten carbide chips that are embedded in a strong but flexible matrix bonded to the steel body of the mill. A boot basket sub should be run above a milling tool to collect metal cuttings created by milling. Steel particles carried up by the circulating fluid will drop into the boot basket when the fluid velocity decreases above the tool. An effective tool to catch the outside of a fish is a circulating and releasing overshot. In the grapple-type overshot, a spiral grapple is employed to catch the fish. A rubber packer seals around the top of the fish to permit circulation. Most overshots can be released by right-hand rotation of the run-in string. Basket-type overshots, instead of the grapple type, are also available. A basket overshot generally requires more outside clearance than the spiral grapple type for a given size fish. If clearance between fish and casing is too small to permit use of an overshot, an internal catch tool may be used. An effective internal catch tool is the releasing spear. The spear provides positive internal engagement of the fish and is releasable. Several types of spears are available, most of which are equipped with pack-off devices to permit circulation through the fish. The taper tap is also used to engage a fish internally. The taper tap employs sharp carburized cutting threads to engage the fish. If the fish has parted at a connection and its threads are still intact, it may be engaged with a pin tap. The pin tap is merely a connection with threads like the pipe or tubing being used. In rare conditions, a safety joint may be run as part of the fishing assembly. While not recommended, in some cases it may be necessary to provide a back-off joint from the fishing assembly. Under most conditions, a back-off joint can be made with a string shot or jet cutter. A safety joint usually consists of two main parts. The lower section stays on the fish and can be re-engaged for subsequent fishing operations. The upper section, when disengaged, is recovered with the fishing string. To recover a fish, the fishing tool assembly is run into the hole until the catch tool, in this case an overshot, contacts the fish. The run-in string is then rotated to work the tool over the fish, and the string is lowered. The fish is then engaged, and circulation, if desired, is started. The fish is free, as determined by additional weight when the string is raised. The fishing string and fish are pulled out of the hole. Removal of pipe or tubing, which has become stuck in a well, requires more precise methods and specialized equipment. Tubing often becomes stuck in a cased hole because of a stuck packer, contaminated mud, sand, junk, or perhaps a combination. If the string has not been parted, and unless experience suggests otherwise, it is always best to work and attempt to circulate a stuck string of pipe before beginning fishing operations. Pulling stretch in the string and working the pipe with pump pressure applied may free the whole string of tubing. Well records should be checked. It is absolutely essential that the fishing tool operator knows the condition of the well and the size, weight, and grade of tubing, as well as details of tools in the hole. Depth measurements are most important. Pipe stretch can be used to estimate or calculate depth to the stuck pipe. The stuck point may also be located with an electronic free-point indicator, available in sizes as small as 1/2 inch in diameter. The indicator is run inside the tubing or drill pipe on a wireline conductor, which transmits electrical impulses to instruments on the surface. The stuck string of pipe is stretched up and down while observations of these impulses are being made. The free-point indicator is extremely sensitive and will permit observation of microscopic movement or molecular stress in the string above the stuck point. As the tool goes below the depth at which the string is stuck, electrical indications of pipe movement cease. The depth of the free point is determined by measurement of the conductor line. If circulation cannot be established, it may be desirable to perforate the tubing near the stuck point to permit circulation. But first, the tubing record should be checked for the presence of a circulating valve, which may be opened by a wireline tool. If the drill string is stuck, it may be necessary to run a wireline string shot and back off. This is accomplished by holding left-hand torque on the stuck drill string at the surface and detonating an explosive charge to cause a coupling to unscrew, thus parting the string of pipe. The string shot, which may be run with a free-point indicator, is a length of primacord explosive detonated by an electrical cap. The string shot is run on a wireline conductor cable with a collar locator to establish the location of the tubing joint or coupling. As left-hand torque is applied to the string and held at the surface, the string shot is detonated at least 2 joints above the stuck point. The jar of the explosion will cause the threaded connection to unscrew. As explosives are used, this operation is hazardous and should be attempted only by specialists and experienced personnel. Back-off may also be accomplished by using a reversing tool. The reversing tool is a device which provides a means of reversing the direction of rotation of the string below it and eliminates the need for a complete string of left-hand pipe. The reverse rotation is accomplished by a planetary gearing system. The tool is anchored by friction dogs engaged on the casing walls so that right-hand rotation of the working string above the reversing tool will produce left-hand rotation of the string below. The fishing string is made up with a catch tool below the reversing tool to engage the fish. When the overshot has firmly engaged the fish, the anchoring device is activated and right-hand rotation is begun. When back-off is accomplished, the rotary will spin free. The fishing assembly can then be pulled out of the hole with one or more lengths of pipe. It is often necessary to cut a section of pipe or tubing in order to remove it. Among the cutting tools available are chemical and jet cutters, which are run on wireline conductors, and internal or external cutters that are run on pipe. The chemical cutter uses a powerful blast of hydrofluoric acid to cut the pipe. It is run into the well on a wireline conductor and activated from the surface. A shaped charge or jet cutter is also run into the well on a wireline conductor, but uses an explosive charge to cut the pipe. External or internal cutting tools are run into the well on a string of pipe. They employ hardened knives to do the cutting. The knives can be actuated by weight or hydraulic pressure. After the pipe above a cut or back-off has been removed, it is then possible to start operations to free the section of pipe that is actually stuck. In many instances, a stuck string of pipe can be freed by an upward jar. If the stuck pipe cannot be loosened in this manner, it may be desirable to run a string shot through the fishing string to back off part of the stuck fish. A hydraulic jar is used to obtain a sharp upward blow on a stuck fish. It is composed of a sliding mandrel and piston assembly that works inside a cylinder which contains hydraulic fluid. Tension is applied by raising the string, and the mandrel piston moves upward in the cylinder. This upward motion initially is impeded by a restricted area in the metering section of the tool. When maximum stretch of the run-in string is reached, the mandrel piston reaches the end of the restricted section and moves into the unrestricted area of the cylinder. It is suddenly released, thus permitting the mandrel to travel upward at high velocity, and the mandrel piston or hammer strikes the top of the cylinder with an upward blow having very high impact. The accelerator jar is optional, but may be used to greatly increase the impact of the blow delivered by a hydraulic jar. An accelerator jar between a jar and the fishing string will intensify the upward jarring effect on a fish. Upward pull on the string will compress the nitrogen gas in the accelerator jar as the mandrel in the hydraulic jar begins its movement. When the mandrel in the jar reaches its free point and is released, the compressed gas above the piston in the accelerator jar expands. This permits the drill collars to travel upward at an accelerated rate, and the hammer of the jar will hit the anvil a very hard blow. The hydraulic pulling tool provides another means of exerting an upward pull on a stuck string. In contrast to the hydraulic jar, the hydraulic pulling tool provides a strong, steady pull on the fish. The assembly of tools to run a hydraulic pulling tool will include a catch tool, an overshot in this case, safety joint, bumper jar, and the hydraulic pulling tool. Note that the cylinder section is below the anchor and control valve. The hydraulic pulling tool has three sections: the pulling or cylinder section, the anchor section, and the relief or control valve. The tool is anchored to the casing, thus a strain on the upper fishing string does not take place when a pull is being made. High-pressure fluid applied to the pistons in the pulling section causes an upward pull on the fishing string below. Hydraulic pressure is obtained from a special high-pressure pump on the surface. If the fish cannot be quickly freed by jarring or pulling, it will be necessary to begin washover operations. Washover pipe is used to go down over the tubing or drill pipe, cut a clearance between the fish and the casing, and by circulation to remove the sand or other material surrounding the fish. The leading edge of the rotary shoe is fitted with fragmented tungsten carbide for cutting and has side openings to permit circulation. Several designs are available for milling both inside and outside. A shoe should be selected that will not damage the casing. The washover string is lowered over the fish and rotated using normal circulation. The rotary shoe cuts through the sand, contaminated mud, or other debris that is then carried to the surface in the circulation fluid. When the fish is washed over, the washed over section is ready for recovery. Recovery may be accomplished in various ways. One method makes use of an external cutter instead of the washover shoe. After washover, the external cutter is used to cut the fish. The fish is then caught with an overshot in the cutter assembly. Terminal fishing refers to the operation of totally milling up or otherwise fragmenting objects left in the bore of a well. Some packers, for example, are constructed so that they may be removed in this manner. There are several mills available for terminal fishing, but in cased holes, the mill selected must be constructed so it will not damage the casing. The fishing string should include a junk basket to collect the debris produced by milling and a guide to center the fishing string in the hole. We have covered most of the major cased hole fishing tools and some of the most commonly used fishing techniques. But each fishing problem is unique, and the methods covered in this program are frequently modified to meet specific requirements.